Hello friends, today we will be learning an important topic in trigonometry, 30, 60, 90 theorem, and then we will be having some values. See here, the 30, 60, 90 theorem says side opposite to 30 degree is equal to 1 by 2 into hypotenuse. The second part of this is side opposite to 60 degree is equal to root 3 by 2 into hypotenuse. Now this has to be proved, and gradually we will find the sine, cos, tan for 30 as well as sine, cos, tan for 60 degrees angles. What is given? Side opposite to 30 degree is half of hypotenuse. Let us consider a triangle, right angle triangle ABC. At B it is 90 degree. Consider angle C as 30 and consider angle A as 60. Now just consider this AB as small a. The value given for side AB is A. According to this, side opposite to 30 degree, that is AB, here we can say side AB is equal to 1 by 2 into hypotenuse is AC. The value for AB considered is A. A is equal to 1 by 2 into AC. AC is equal to 2A. So here we will be writing AC is equal to 2A. Next part, side opposite to 60 degree is root 3 by 2 into hypotenuse. Now here, side opposite to 60 degree is BC. So here I give BC is equal to under root 3 by 2 into hypotenuse, but the hypotenuse calculated here is 2A, so I write here 2A. 2 cancels and we say BC is equal to root 3 into A. Now we need to even check whether the things we have assumed are proper or not. And the best thing for this is Pythagoras theorem. In triangle ABC, if I apply Pythagoras theorem, it will be hypotenuse square, that is AC square, is equal to sum of the squares of the remaining two sides, that is AB square plus BC square. This is what Pythagoras says. So AB square plus BC square now we will substitute the values. AC is 2A whole square, AB is A square plus BC is root 3 into A whole square. 2 square is 4, A square is, as it is A square, it becomes 4A square is equal to A square plus root and square cancels, 3A square. Here we have 4A square is equal to 4A square. The values that we have considered are totally satisfying the Pythagoras theorem. Now let us move to 30 degree with all three ratios. Consider sine 30, cos 30 and tan 30. Sine 30 is opposite upon hypotenuse. Cos 30 is adjacent upon hypotenuse. Tan 30 is opposite upon adjacent. Now if I consider this as 30 angle, the opposite side is AB. and the hypotenuse AC, it becomes AB upon AC. The adjacent side is BC and the hypotenuse is AC. So BC upon AC. The opposite side is AB and the adjacent side is BC. It becomes AB upon BC. Now substitute the values. What do you get? C. Sine opposite upon hypotenuse. A upon 2A. It becomes A upon 2A. That means 1 by 2, as this A is going to get cancelled. Adjacent upon hypotenuse, root 3A upon 2A. It becomes under root 3A upon 2A. AA cancels. This becomes under root 3 upon 2. Opposite upon adjacent, A upon root 3A. Here I can write A upon root 3A. AA cancels. I have 1 by root 3. So friends, the values for sine 30 is 1 by 2. The value for cos 30 is root 3 by 2. And the value for tan 30 is 1 by root 3. Same thing can be exhibited in a different way. Instead of 30, 60, 90, I take one more theorem, 45, 45, 90. Now instead of these two angles, 30 and 60, I am going to consider 45 and a 45 here. This is 90, a right angle triangle again. Sorry. ABC is the right angle triangle at B. B is 90 degree. A and C, both the angles are 45 each. Now, you know, the side opposing the congruent angles is also congruent. So instead of taking here just A, I will be taking an A here also. Now by Pythagoras theorem, what happens here? A square plus A square is equal to AC square, or in simple words, AC square is equal to A square plus A square. AC square is equal to 2A square. AC is equal to under root 2 into A. Here it becomes under root 2 into A. 45, 45, 90 theorem states that side opposite to 45 degree angle is A here, side opposite. You consider this angle or this angle, it's A. Now, side opposite to 45 degree angle is 1 upon root 2 times A. 1 upon root 2 times A. If I consider sine theta or sine 45 here, cos 45 and tan 45. This becomes opposite upon hypotenuse. That means AB upon AC. It becomes A upon root 2A. AA cancels. What I get is 1 upon root 2. If I consider cos 45, or I consider this angle adjacent upon hypotenuse, A upon root 2A again, AA cancels and you get 1 upon root 2. Tan 45 is opposite upon adjacent, A upon A. Here I write A upon A. Answer is 1. We have developed 9 different values. Sin 30, 1 by 2. Cos 30, root 3 by 2. Tan 30, 1 by root 3. Sin 45, 1 by root 2. Cos 45, 1 by root 2. Tan 45, 1. And 3 more values. I told you 9 values, out of which 6 are seen here. Remaining 3 values. That means I need to find out sin 60, cos 60 and tan 60. The way in which I found out sin 30, 60, 90, cos 30, 60, 90, in the similar way I'll try to find out sin 60, cos 60 and tan 60. See here, sin 60 is opposite upon hypotenuse. That means under root 3a upon 2a. A cancels. Answer is root 3 upon 2. Next is cos 60. Adjacent upon hypotenuse. That is equal to a upon 2a. A cancels. Answer is 1 by 2. And then tan 60, that is opposite upon adjacent. So root 3a upon a cancel. Answer is root 3. Now we can say that we found out 9 different values. Sin 60, cos 60, tan 60. Sin 30, cos 30, tan 30. Sin 45, cos 45, tan 45. After going through 9 values, I would like to explain you how to write the table in which we'll add 2 more angles, angle 0 and angle 90. For students, those who do not mug up, it could be very easily written on the paper how to remember the values. I have sin theta, cos theta and tan theta. These are the different values. And we'll see different angles now. 0, 30, 45, 60, 90. Few things we need to remember. We need to remember very, very simple things out of which this complicated table gets converted or developed. Sin 30 is 1 by 2. That's all. First thing to remember is sin 30 is 1 by 2. So I write here 1 by 2. Everybody knows, in my previous lecture it was mentioned, sin theta is equal to cos 90 minus theta. Here theta is 30. So sin 30 is equal to cos 90 minus 30. That means cos 60. Agreed? Sin 30 is equal to cos 60. Value remains same. Sin 30 is equal to cos 60. So here also I need to write the same value. Second value that I need to remember is root 3 by 2. Cos 30 is root 3 by 2. Cos 30 should be equal to sin 60, as cos theta is equal to sin 90 minus theta. Here cos 30 is root 3 by 2. The same value has to be sin 60, root 3 by 2. Now we know tan is equal to sine upon cos. So this value upon this value, 1 by 2 whole upon root 3 by 2. 2 denominator cancels, and what do you get? 1 upon root 3. Here 2 denominator cancels, you get root 3 upon 1, that is equal to root 3. So we made all three values. Now we'll move towards 45. One thing we need to remember here is sine and cos 45 is 1 upon root 2. Same thing for cos, 1 upon root 2. Sine upon cos, same number as numerator and same number as the denominator, you get 1 as the answer. Now the last thing that you need to understand here is, understand a number 0, 1, 0. So 0, 1, 0. Start from the same point, 0, 1, 0. You know, 0 upon 1 can be written as 0. But what if 1 upon 0 you have? It cannot be defined. So write down here, undefined. So this is how we remember. For standard 9th, we'll have only this part which is in use. For standard 10th or higher studies, we may add here after 90, 180, and here instead of sine, cos, tan, we'll have 6 ratios in all. 3 are shown here. Reciprocal of tan is cot, reciprocal of cos is sec, and reciprocal of sine is cosec. Okay, so we have 6 ratios and 6 angles. In all, 36 values can be generated. So these are certain points which should be remembered in order to solve the trigonometric problems. I hope this video is a useful one for you. If you feel that this video is really worth, please like, share and subscribe my channel. Thank you very much. Let's have few more videos in coming days. I'll come up with you with few more videos. I'll be coming up. So stay tuned. Thank you very much.